Hello learners, and welcome to today's lesson of similarity and congruency, where today we are going to focus on those practice and application questions. Let's get to our practice questions. So the first question there says, determine if triangle ABC is similar to triangle PQR. Now, if you remember the conditions of proving that two triangles are similar, it's either we will prove that the ratio of the corresponding sides are in proportion, or we can prove that all the interior angles are equal. So let's look at these two triangles that we have been given here. We can see that the triangles, they look like they are similar, but we need to prove that they are similar using, or to determine if they are similar or not, using the conditions of similarity. So we have been given angle A as 65 degrees. We've been given angle C as 25 degrees, and angle B is not given to us, but we can calculate angle B. So if we say angle A plus angle B plus angle C is equals to 180 degrees, and our reason for saying that is because they are the interior angles of a triangle. So angle A is 65 degrees, angle B is not given to us, and angle C is 25 degrees. And when we want angle B, we are going to add 65 degrees with 25 degrees, and that gives us 90 degrees. Now, if we want to calculate what B is, we are going to use the additive inverse of 90 degrees, and that will leave us with 180 degrees minus 90 degrees, which is going to give us 90 degrees. So it means that angle B is 90 degrees, and we can use the symbol for 90 degrees to represent that angle there. Now let's look at this second triangle here. Now with the second triangle, we have been given a 90 degrees, and we do have a 25 degrees. Now let's calculate that third angle so we can see if it corresponds with our first triangle. Now we know that the 25 degrees plus the 90 degrees, which are those given angles, plus angle P, that is going to give us 180 degrees. And the reason for this is that they are interior angles of a triangle. And as we know, the interior angles of a triangle are supplementary. So 90 degrees plus 25 degrees, that gives us 115 degrees, plus angle P is equals to 180 degrees. And if we use the additive inverse of 115, then we are going to be left with a value for P that is 65 degrees. So we can see that angle P is 65 degrees. Now, looking at our two triangles, we can see that angle A is equals to angle P. And we can see that angle B is equals to angle Q. And we can see that angle C is equals to angle R. Now, all of the corresponding angles are equal. What does that mean? That means that we can conclude that indeed triangle ABC is similar to triangle PQR. And in that way, we have proved that these two triangles are similar. Let's move on to the next example. So the next example here has, again, two triangles, and we need to determine whether these two triangles are congruent or not. Now, both of these triangles are isosceles triangles. So we have MH equals to ML, so that means ML is also 9 centimeters. We have DE equals to DF, which means that DF is also 9 centimeters. Now, in this first triangle, we already have a side and the included angle and another side. So two sides and an included angle. And remember, that is a condition to prove congruency. And we are trying to determine whether these two triangles are congruent or not. So we need to see if triangle DEF is congruent to triangle MHL. So in the one triangle, we already have a side, the included angle, and another side. So let's see if we can get the same for this first triangle here. So firstly, because angle L is 63 degrees, it means that angle H is also 63 degrees, because angle H and angle L, they are opposite equal sides, which makes them equal as well. So when we are looking at the interior angles of a triangle, we know that the 63 degrees plus the 63 degrees plus angle M, that is going to give us 180 degrees. And we are saying this because these three angles are the interior angles of a triangle. And we know that those interior angles of a triangle add up to 180 degrees. Now 63 plus 63 is 126 degrees. And that is equals to 180 degrees when we add 126 degrees plus M. And using the additive inverse of 126, we are going to get a final answer of angle M being equals to 54 degrees. And that comes from 180 minus 126. So that is 54 degrees. Now, as we can see here, we do see that angle DE is equals to angle MH. And we see that angle DF is equals to angle ML. But if we look at the included angle between those two sides, we have angle D as 52 and angle M as 54. So we can see that angle D is not equal to angle M. And because of this, this means that triangle DEF is not congruent to triangle MHL. Why? Because if we look at the given information or the information that we calculated, we can see that the conditions for congruency are not met. Let's go over to the next one. So here we also need to determine if triangle PQR is similar to triangle LNM. Now we have been given the lengths of all the sides in both triangles. So let's see if they are similar or not. And remember, one of the conditions for similarity is to see if the ratio of the corresponding sides are in proportion. So let us take here PQ divided by QR. So let's first calculate what this ratio will be. So we can see that PQ has been given as 18 centimeters and QR has been given as 9 centimeters. Now what is 18 centimeters divided by 9 centimeters? Now this will give us 2 divided by 1, and those are the sides for the triangle on the left hand side. Now let's look over on the corresponding sides of the smaller triangle so that we can see if these two triangles are similar. So in the smaller triangle, so in the bigger triangle, we saw that we took PQ and we divided it by QR. Now we need to make sure that we have the corresponding sides. So which side do you think corresponds with PQ? Well, if you are thinking of NL, then you are absolutely correct. As we can see, PQ is the largest side of that triangle, so NL or LN is also the largest side of the smaller triangle. So we are going to say LN, and we are going to divide it by the corresponding side to QR. And if we look at QR, it is the smallest side of this triangle on the left-hand side. So let us go and look for the smallest side of the smaller triangle. So this would be NM. Now, what is the length of LN? This is 6 centimeters. And we are going to divide this by the length of NM, which is going to be 3 centimeters. And now our final answer is going to be 2 divided by 1. And as you can see, the ratio of the sides, or of the corresponding sides, they are in proportion. Now, this could have been true for any two corresponding sides that we might have taken. So we can now test if that is true by taking another pair of sides. We can even start with the smaller triangle, and let us take ML, and we are going to divide this by NM. So ML is 5 centimeters and NM is 3 centimeters. Now this is going to give us a ratio of 5 divided by 3. So that is the ratio of those sides in the smaller triangle. Which ones are the corresponding sides in the larger triangle? So we can see if the sides are in proportion, if the corresponding sides are in proportion. So we already know that the corresponding side to NM is QR. So what is the corresponding side to ML? If you are thinking that it is PR, then yes, you are correct. So we are going to have the PR divided by the corresponding side to NM, which is our QR. Now, the length of PR is 15 centimeters and the length of QR is 9 centimeters. The ratio of these two sides, when simplified, is 5 divided by 3. So as you can see there, that again, the ratio of the corresponding sides is in proportion. So what conclusion can we make there? We can conclude that therefore triangle PQR is indeed similar to triangle LNM. And of course, our reason for this would be that the ratio of the corresponding sides are in proportion. And because these two triangles met one of those conditions that we need for proving two triangles or proving two shapes to be similar, then we can conclude that indeed these two triangles are similar. Let's quickly go to an ad break and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. Let's go on to those application questions. So we have the first one here that says that prove that a triangle RST is similar to triangle ABC. So we are proving similarity here. That means that we can use our angles, since we can see that these two triangles, they do not have the given sides. So we are going to use our angles. And for us to prove that they are similar, that means that all three angles must be, or the corresponding angles, they must be equal. So let's start with triangle RST. Now we have been given the reflex angle of 338 degrees. But we are looking for that interior angle there. but we can use this given angle to find the interior angle. Why? Because we know that angles around a point are equals to 360 degrees. So it means that that given angle of 338 degrees, when we add that interior angle of triangle RST together, they should give us that angle of 360 degrees, because it is angles around a point. So let's see how we can calculate that. We know that it's going to be the 338 degrees plus that interior angle S, and that is going to be equals to 360 degrees, and the reason for that will be angles around a point, or we can say a revolution. So using the additive inverse of 338 degrees, so that would mean that our our angle S will be equals to 22 degrees. So we know that that angle there is 22 degrees. Then we do have a given angle of 86 degrees, so we just need to find our third angle, which is angle R. So that would be our 22 degrees plus our 86 degrees plus angle R, and that is equals to 180 degrees. Now, what is our reason for saying that? It's because these three angles are the interior angles of a triangle, and the interior angles of a triangle are supplementary. So 22 plus 86, that will give us 108 degrees plus angle R, that's equals to 180 degrees. And now using the additive inverse of 108 degrees, then our answer is going to be 72 degrees, and that is angle R. Now looking over to this second triangle there, we can see that we have been given 22 degrees, and we've been given an exterior angle of 108 degrees. Now what do we know about an exterior angle? We know that the exterior angle is equals to the sum of the opposite two interior angles. So this would mean that the 108 degrees is equals to 22 degrees plus angle C, because those are the two opposite angles, and it is equals to the sum of these two opposite angles. So angle C can be found by using the additive inverse of 22 degrees. So this means that angle C is equals to 86 degrees. And of course, don't forget to write that reason. The reason why we're saying 108 degrees is equals to 22 degrees plus angle C is because of the exterior angle of a triangle. Remember, the exterior angle of a triangle is equals to the sum of the two opposite interior angles. And from that calculation, we can see that angle C is equals to 86 degrees. So what is the value of angle A there? So angle A there, we can see that the interior angle there at angle A, we can see that it shares a common vertex with the exterior angle, which is 108. And as they share a common vertex and they are on a straight line, it means that the sum of both of these angles is 180 degrees. So it means that that interior angle of A plus this 108 degrees are equals to 180 degrees. And why are we saying that? It's because the two angles are on a straight line. And angles that are on a straight line, they add up to 180 degrees. Right? So we have angle A would be equals to 180 degrees minus 108 degrees, and this is because we are using the additive inverse of our 108, and our answer there is going to be 72 degrees. So angle A is equals to 72 degrees. Now looking at our two triangles, what can we see there? We can see that angle A is equals to, we can see that angle A is equals to angle R. We can see that angle S, which is the interior angle there in that triangle, is equal to angle B. And we can see that angle C is equals to, let's rather write it like this. So that is angle B is equals to angle S. And we can see that angle C is equals to angle T. So what conclusion can we make about our two triangles? We have now proven that triangle RST is indeed similar to triangle ABC. And our reason for that is because all the corresponding sides are equal, or we can simply even say that it is A, to show that all of the angles are equal. Let's move over to the next example. So we are told here that AB is parallel to CD and AE is equal to DE as we are shown in our diagram. Prove that triangle ABE is congruent to triangle DCE. Now, let's start with the given sides. So we are told that AE is equal to DE, and that of course is given to us. So we can see that AE is equals to DE. We also have E1 equals to E2, and the reason why we are saying that is because they are vertically opposite angles. Now you remember, how do we identify the vertically opposite angles? Now the vertically opposite angles, they share a common vertex and they are on opposite sides of that common vertex, but most importantly, they are formed when two lines intersect. So when two straight lines are intersecting, then they form those angles there. So we can see there that E1 is equals to E2 over there. And then lastly, we can use our parallel lines to prove or to show that angle D is equal to angle A. So as we can see there, we can see that because we have parallel lines, that means we have alternate angles as we have shown there. So that means that angle D is equals to angle A, and that is because of the alternate angles. And that is, they are only equal because AB is a parallel to CD. So what conclusion can we make? We can make the conclusion that ABE, or triangle ABE, is congruent to triangle DCE. And what is our reason for that? Is because we found two angles and a corresponding sides. So how are we going to write that? We are going to write there that we found an angle, we find a corresponding side, and we found another angle there. Let's look at our next example where we are also going to be proving their congruency. So number 3 there says angle Q is equals to angle R, and PQ is equals to RS, as we can see that it is shown on the diagram. Now prove that a triangle PQR is congruent to triangle SRQ. So from the given information, we are told that QR, or angle Q, is equals to angle R. Then a PQ is equals to RS. Right? So we already have two corresponding things in our diagram. So we have a corresponding angle that is equal, we have a corresponding side that is equal. And congruency, remember, needs three things. So we have a side and we have an angle. Now, but when we look closely, we can see that QR is part of PQR, but it is also part of SRQ. So that means that QR is a common side for these two triangles. So what does this mean? It means now we have a side, we have the angle that is included there because we were told that the other side also is equal. So that means we have two sides and the included angle. So therefore, we can conclude there that indeed triangle PQR is congruent to triangle SRQ. And what would be our reason for that? It's because we have a side, an angle, and another side. So that is two sides and the included angle. Let's quickly go to an ad break and then we'll see you just now for the rest of our lesson. Welcome back from the ad break, and let's continue with our lesson where we are going to wrap up what we learned during this lesson. So looking at our concept map, we saw that we were looking at a similarity, then we looked at congruency, and of course we solved some of those problems. Then looking at the keywords that we used during this lesson, we were looking at similar triangles, we were looking at proportional, then we had corresponding sides, and we also looked at congruent triangles. Now, let's look at the things that you should remember or keep in mind when we are working with similarity and congruency. Firstly, when two polygons are similar, they have the same shape, but not necessarily the same size. The similarity of two triangles can only be proven using corresponding sides. All the corresponding sides must be in proportion for the triangles to be similar. All the corresponding angles must be equal for the triangles to be similar. When two polygons are congruent, they have the exact same shape and the exact same size. The congruency of two triangles can only be proven using the conditions for congruency, namely side, 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 angle, side, two angles and a corresponding side, and a right angle, hypotenuse, and a side. Let's end our lesson with a nice challenge. So the polygon below is given. Prove that triangle ABD is congruent to triangle CDB. So that is a nice challenge that you can go and do, but I know you can do it. Thank you for joining us for our wonderful lesson. I enjoyed it, and I hope you enjoyed it too. We hope to see you next time. Goodbye.